Okay, so this is all about cancelling fractions. Now, can we see a whole with 15 equal pieces? Yep. Okay, so if I shaded 3 of those, what would the fraction be? 3/15. Okay. And reducing that to simplest form would give you 1/5. So how did you do that? How many 3's go into 15? And the answer is 5. So basically you did divide by 3, divide by 3. Okay, that's correct. Now, we need to be able to see the relationship between the numerator and denominator when we cancel fractions. And the way that we do that is we rewrite it slightly. And it's important to know how to cancel fractions and when you can cancel fractions if we're doing algebra. Okay? So that's a group of 3, yeah? Okay, let's create another group of 3. Another group of 3. Another group of 3. And another group of 3. How many groups of 3 do I have? 5. I have 5 groups of 3. Okay, so the way that cancelling works is we go, okay, 3 on 15 is equal to 1 group of 3 out of 5 groups of 3. Can we see the 1 group of 3? And can I see the 5 groups of 3? Okay. It's the whole, exactly. 5 groups of 3 is the whole. Now, do we know how to multiply fractions?
Yes.
And how do we multiply fractions?
You times the numerator by the other numerator and the denominator.
So you times the numerators together, you times the denominators together. Yep. Okay. So can I do this? 1/5 times 3 on 3. Is that exactly the same thing as this one?
Yeah.
Yep. Okay, and then I look at this. What's 3 divided by 3?
1.
That's equal to 1. Now what's 1/5 times 1? What's any number times 1? Just the number. So what's 1/5 times 1? 1/5. Okay. So if I change the problem, let's make it this. 1, 2, 3, 4, 5 out of the whole of 15. So what's the fraction? 1/3 is the answer. But 5 on 15 would be the unsimplified form. Yep. And then we're looking at groups of 5, aren't we? Because here can be split, divided by 5, here can be divided by 5. So here's one group of 5. Here's 1, 2, 3, 4. There's another group of 5. 6, sorry. Trying to do it right. 1, 2, 3, 4, 5. Yep. And there's another group of 5. So, do you guys agree I could write that as one group of 5 out of 3 groups of 5? Yes? And if we know how to multiply fractions, we can do this. 1/3 times 5 on 5. And what's 5 divided by 5? What is 5 divided by 5? 1. And you have 1/3 times 1, which is 1/3. Okay, let's do some harder ones. Okay, we're going to try and simplify that.
So you have to times each number by the other number, so 300 times.
Why would you do 300 times 224?
I'm not quite sure.
Yeah, what we notice is that these are even, the numerator's even, denominator's even. So one strategy is to keep on halving. Alright? Yes? So let's do it with writing out multiplication and cancelling. Alright, so 62 times 2, or 2 groups of 62 or whatever, over 150 times 2. Yep. The reason I'm doing this is so that you know when you can cancel. You can only cancel when it's all multiplication on the top, all multiplication on the bottom, and you have common factors. Because the 2 on 2 goes down to 1. Yeah? The 2 on 2 cancels to 1. Okay, then I'll look at the numerator and denominator. They're both even again, so maybe halving is a good strategy. Yeah? So I would get 31 on 75 as my answer. Yeah? And then I'm done. There's no other number that will go into 31 and 75. Yeah? Okay. Here's another one. What would you guys do?
Just times 1 by 4 and 4.
So you want to times 1 by 4, and then 4 by 5, and then reduce. That's what you want to do? Yeah, we can do that if we know multiplication of fractions. What you do is you multiply the numerators, multiply the denominators. But we want to make it as simple as we can, as simple as possible. Alright? Well, I'm going to use the cancelling trick. And I'm going to use the commutative property, which says the order of multiplication doesn't matter. Okay, so for example, does 3 times 4 equal 4 times 3? Yes? Does 2 times 3 times 4 equal 4 times 2 times 3? Yes? So I can swap the order around, doesn't matter. True? Okay, so let's swap the order here on the numerator. I'll get 4 times 1. True? Well, you just told me that the numerators you can multiply together. Yeah? And you told me that the denominators can be multiplied together. So that means that I can just swap the order because I know that the order of multiplication doesn't matter. Yeah. Now it's 4 divided by 4. 1. So what's my answer? 1/5. That's cool. Because you don't have to do that arithmetic if you know what's happening.
Does that work for all of it?
It works for whenever you have all multiplication on the top and all multiplication on the bottom. Okay? So it's also, we could just think about this problem really, 1/4 of 4/5. Okay, so here's my whole. I split it into fifths. Right? I have 4 of them. Okay, and now what I'm doing is taking 1/4 of my new whole amount, which is my 4/5. 1/4 of my 4/5. So what's 1/4 of the 4/5? The relation to the whole that I started with. Isn't it just 1/5? Yeah, 1/4 of the 4/5 is 1/5. It's like saying you had a whole pizza cut into 5 equal pieces. Yeah. You ate one, so you only have 4 of them. And then you took 1/4 of that amount. You would have 1/5 the slice of the normal whole pizza. Yeah? Okay. So, let's continue. Another example. If we go 2/3 times 3/4, what do we do? Okay, we can swap the numerators around because we know the order doesn't matter. So 3 on 3 is 1, and 2 on 4 is a half. So cancel, you get a half.
What happens when the numerator on one of, say, 3/4 is like 2? If it's like 2/4.
If it's 2/4, we do that example. Okay, there's no way of doing a straight cancel, right? But what you could do is you go 2 on 4 is a half, so I'm going to write that down. Now can you see cancellation? Yeah? What is it?
1/3 times 2, 1.
So you're saying swap the numerators and you get 1/3 times 2 on 2, cancel, you get 1/3.
I mean, what if it's like, I don't make sense to, but like, if it's like a complete different number.
It's a complete different number, then you might have to do the multiplication. However, at some point we should be able to see this. Right. If I did my swapping of things around and getting things to be multiplying by 1, I would just have the 4's cancelling, the 5 cancelling, the 4's cancelling, and I'd be left with 3 on 6, which is a half. Yeah? 3/4 times 4/5 gives you 3/5. So if it's all multiplication on the top and all multiplication on the bottom, you can do some cancelling. We'll do some more examples.